Welcome back. This is an Aleks homework video on using first and second order integrated rate laws. Okay, an integral is an operation from calculus, but you don't necessarily need to understand calculus fully in order to do this. It's simply taking a first rate law and a second rate law, or a first order rate law and a second order rate law, and doing an operation on it and finding a formula that you could write down or memorize. So if you were to do a first order rate law, so let's do that first because I don't know which problem you'll have one or the other. So if you do a first order rate law, the rate is going to equal whatever your constant is times the concentration of whatever you've got, whatever you're looking at. Okay, that's your rate. If you take the integral of that, this is what you'll get. The natural log of whatever the concentration is divided by the concentration of your original equals minus KT. Okay, now remember, when you're solving for T or you're solving for A or whatever, you're going to have to get rid of that natural log, and you do the opposite operation to do that, and usually you're going to do an e to the x button to get rid of that natural log. Think of subtracting to get rid of addition, or dividing to get rid of multiplication, or taking a power to get rid of a square root. It's just basically the same thing. That natural log has to be got out of there if you're going to find a concentration or find a time or something like that. In our problem, we've got a second order. So let's write that one down too. So a second order is going to be, the rate is going to be equal to whatever your K is times your concentration of the stuff we're looking at squared. That's where I remember second order. It's to that second power. And if you take the calculus integration of that, this is what you have to memorize. It's going to be 1 over the concentration of your stuff minus 1 over the concentration of the original amount of that stuff, original concentration, equals positive KT. Okay, so we know that our original was 1.43 molar. And we know that the stuff we're looking at is SO3. So I'm just going to recopy this as 1 over the molarity of SO3 minus 1 over the amount that I know. And I know it as 1.43 molar concentration. And now I need KT. So this is positive 0.00434, and we're in molarity per second on the bottom, times 910 seconds. So seconds will cancel with seconds, leaving me molarity on the bottom. All right, so let me go ahead and multiply those two. 0.00434 times 910 equals, okay, and I'm just going to recopy this on the left, SO3 minus 1 over 1.43 equals, and I get 3.9494. Okay, and that's molars on the bottom, molarity on the bottom. Okay. Now, I'm eventually going to get SO3 concentration by itself, so let's get rid of the other fraction. So I have 1 over SO3 equals 3.9494, molarity on the bottom, plus 1.43, that's molar on the bottom. So I'm just going to take 1 divided by 1.43 equals plus 3.9494. Okay, and then you'll end up with 4.6 0.487 molarity on the bottom. That's going to be 1 over, SO3. So I've got 1 over the concentration. I'm just going to do a reciprocal. I'm going to push the 1 over x button. I've got 4.6487 in my calculator. Push the reciprocal button. Okay, I'll go this way. And I'm going to have the concentration of SO3 equals 0.21511387 molar. Now remember, I had molarity on the bottom, and when I reciprocated, molarity becomes on the top, and that's what I want. I want a concentration. And now I want 2 significant digits. So my answer would be concentration of SO3 equals 0.22 molar. And that is the answer. Okay? I hope it helps you.